Imagine a telescope so powerful it peels back the veil of the cosmos, revealing secrets no other instrument could touch. When the James Webb Space Telescope turned its gaze toward a faint, fleeting object drifting far beyond our solar system, it captured something extraordinary. Oumuamua, the first confirmed interstellar visitor to grace our skies, appeared not as a mere speck but as a chronicle of the universe's untold stories. This enigmatic wanderer, first spotted in 2017, has puzzled scientists and dreamers alike, and now, with Webb's unparalleled vision, we're beginning to unravel its mysteries. Oumuamua isn't just a rock hurtling through space. Its narrow, cigar-shaped form, roughly 800 meters long, defies the rounded shapes of asteroids we know. Its surface, scarred with ridges and pockmarks, tells of a journey spanning eons through the interstellar void. Webb's infrared eyes revealed details that ground-based telescopes could only dream of: a surface dusted with complex organic molecules, compounds that hint at chemistries alien to our solar system. These aren't the simple ices or silicates of our asteroids but intricate chains of carbon-based materials, the kind that could, in the right conditions, spark the seeds of life. What makes this object so tantalizing is its origin. The elements on its surface, unfamiliar metals and rare isotopes, point to a birthplace far beyond our galactic neighborhood. Perhaps it formed in the crucible of a young, chaotic star system, where violent stellar winds forged exotic materials. Or maybe it hails from a region near a supermassive black hole, where gravitational forces sculpted its odd shape. Whatever its home, Oumuamua carries the chemical fingerprints of a place we've never seen, a distant corner of the galaxy where the rules of planet formation might differ wildly from our own. Then there's the matter of its speed. As Oumuamua swung through our solar system, it didn't behave like a typical comet or asteroid. It accelerated as it departed, not slowing as gravity should demand. Early theories suggested outgassing, jets of vaporized ice propelling it like a natural rocket. But Webb's data debunked that idea. No gas plumes were detected, no telltale cometary tail. Instead, the telescope's spectral analysis hinted at something stranger, a surface that reflects light in ways that suggest a metallic sheen, perhaps laced with crystalline structures. Could this be evidence of a light sail, a theoretical propulsion system driven by the pressure of starlight? The idea sounds like science fiction, but the math checks out. A thin, reflective sheet could harness radiation from our sun or distant stars, giving Oumuamua the boost it displayed. This possibility ignites the imagination. What if Oumuamua isn't a natural object at all? What if it's a relic of an ancient civilization, a probe sent to explore the galaxy long before humanity existed? The notion isn't as far-fetched as it seems. Scientists have long speculated about extraterrestrial technologies, and a light sail is one of the few designs we ourselves are developing. Projects like Breakthrough Starshot aim to send tiny probes to nearby stars using laser-driven sails. Could Oumuamua be a distant cousin, a forgotten artifact from a species that mastered interstellar travel? The shiny component on its surface, detected by Webb, might be a clue, a material engineered to withstand the harsh radiation of deep space. Yet, the natural explanations are just as compelling. Another theory suggests Oumuamua is a fragment of a shattered planet, torn apart by the tidal forces of a massive star or a black hole's relentless pull. Imagine a world, not unlike our own, orbiting too close to a cosmic giant. Its crust cracks, its core splinters, and pieces are flung into the galaxy. Oumuamua could be one such shard, carrying the geological history of a lost world. Its uneven shape and battered surface support this idea, as do the traces of heavy metals that hint at a planetary core. If true, this object isn't just a curiosity, it's a time capsule, preserving the story of a cataclysmic event that reshaped a distant solar system. The organic compounds on its surface add another layer of intrigue. These molecules, rich in carbon and nitrogen, are the building blocks of life as we know it. Could Oumuamua have played a role in spreading these ingredients across the cosmos? The concept of panspermia suggests that life's raw materials, or even life itself, could hitch a ride on interstellar objects, seeding planets as they travel. If Oumuamua carried such molecules from its home system, it might have sprinkled them across countless worlds during its billion-year journey. Perhaps, long ago, a similar object passed through a young Earth's orbit, delivering the chemical sparks that led to us. The thought is humbling, this lonely traveler could connect our origins to the stars. Webb's observations also revealed something unexpected. Oumuamua's trajectory suggests it didn't wander aimlessly. Its path through our solar system was precise, almost deliberate, as if guided by forces we don't yet understand. Some researchers propose it could have been nudged by subtle gravitational interactions with dark matter, the mysterious substance that binds galaxies together. Others wonder if its acceleration points to an energy source we can't yet detect, perhaps tied to the exotic physics of its home system. Each new piece of data raises more questions than it answers, reminding us how little we know about the universe beyond our sun's reach. The implications of Oumuamua stretch far beyond its physical form. It challenges our assumptions about what's possible in the cosmos. If it's a natural object, it tells us that interstellar travelers are more common than we thought, carrying materials and histories from distant stars. If it's artificial, it suggests we're not alone, or at least, we weren't at some point in the galaxy's past. Either way, Oumuamua is a messenger, whispering secrets about the universe's structure and evolution. Its brief visit has forced us to rethink our place in the cosmic order, reminding us that our solar system is just one small stage in a vast galactic drama. This discovery has also lit a fire under humanity's ambitions. The data from Webb has fueled plans for missions to intercept future interstellar visitors. Imagine a probe, launched from Earth, racing to catch an object like Oumuamua as it passes through. Equipped with cameras, spectrometers, and perhaps even a lander, such a mission could collect samples, analyze their composition, and confirm whether these travelers carry the seeds of life or the relics of alien technology. The technology to achieve this isn't far off. Advances in propulsion, like solar sails or ion drives, could make such missions feasible within decades. Each step brings us closer to touching the stars, not just observing them. Oumuamua's passage also highlights the power of our tools. The James Webb Space Telescope, with its massive mirror and infrared sensitivity, has given us a window into the universe's deepest mysteries. It's not just about seeing farther, it's about understanding the subtle signatures of light that reveal an object's history. The telescope's ability to parse Oumuamua's reflected light showed us its surface composition, from the organic molecules to the metallic sheen. Future instruments, even more advanced, could track these objects in real time, mapping their paths and analyzing their properties before they slip back into the interstellar void. But what does Oumuamua mean for us, here on Earth? It's more than a scientific puzzle, it's a call to wonder. Its presence forces us to confront big questions. We alone? How did life begin? What else is out there, drifting between the stars? The answers may lie in the next visitor, or the one after that. Each interstellar object we study brings us closer to understanding the galaxy's history and our role within it. Oumuamua's strange journey suggests that the universe is teeming with stories, waiting to be read by those bold enough to look. Consider the broader picture. Our solar system, once thought to be a unique oasis, may be just one of many connected by a cosmic highway of wandering objects. The materials on Oumuamua's surface, metals, organics, and unknown compounds, hint that other systems might host chemistries similar to ours, or wildly different. If life exists elsewhere, it could share a common origin, carried by objects like this one. Or perhaps life is more diverse than we imagine, shaped by environments we can't yet fathom. Oumuamua's chemistry offers a glimpse into those possibilities, a clue to the diversity of worlds beyond our own. The object's reflective surface also raises practical questions. Its shininess, far greater than most asteroids, could be due to a layer of crystalline minerals or even a metallic coating. This reflectivity might explain its acceleration, as starlight pushed against it like wind on a sail. But it also suggests Oumuamua could have been altered by its travels, polished by cosmic rays or coated by interstellar dust. Each mark on its surface is a record of its journey, a map of the hazards it faced in the galaxy's depths. By studying these marks, we learn not just about Oumuamua but about the environments it passed through, regions of intense radiation, dense star clusters, or even the edges of black holes. The idea of Oumuamua as a planetary fragment opens another door. If it's the remnant of a destroyed world, it could carry clues about planetary formation and destruction. Planets form from disks of gas and dust, but what happens when they are torn apart? Oumuamua's composition, rich in metals and lacking volatile ices, suggests it came from deep within a planet, perhaps near its core. This makes it a rare opportunity to study the interior of a world we'll never visit. Its journey through our system is like a gift, offering a piece of a distant planet for us to analyze. The possibility of panspermia adds a layer of existential weight. If Oumuamua carries life's building blocks, it could mean that the galaxy is a network of interconnected systems, sharing materials across vast distances. Life on Earth might owe its existence to an object like this, drifting through billions of years ago. The organic molecules on Oumuamua's surface aren't alive, but they are the raw ingredients for life: carbon chains, nitrogen compounds, and perhaps even amino acids. If these molecules are common in interstellar space, life might be less rare than we think, scattered across countless worlds by objects like this one. The light sail hypothesis, while speculative, can't be ignored. A light sail doesn't require an advanced civilization, just a material thin and reflective enough to catch starlight. Oumuamua's acceleration and reflectivity fit this model, though natural explanations, like a highly polished surface, are equally plausible. Still, the idea of an artificial object forces us to consider the longevity of technology. If Oumuamua is a probe, it could be millions or even billions of years old, built by a civilization long gone. Its survival through interstellar space would be a testament to its design, a challenge to our own engineering ambitions. The scientific community has responded with fervor. Oumuamua's discovery has spurred new research, from modeling its trajectory to analyzing its composition. Teams are already designing missions to chase similar objects, using telescopes to spot them early and spacecraft to intercept them. The Vera C. Rubin Observatory, set to scan the skies in the coming years, could detect dozens of interstellar visitors, giving us more chances to study these cosmic nomads. Each one could reveal new insights, from the chemistry of distant stars to the mechanics of galactic collisions. Oumuamua also challenges our technology. Building a probe to catch an object moving at tens of kilometers per second is no small feat. It requires propulsion systems far beyond our current rockets, perhaps nuclear engines or laser-driven sails. These technologies, once the stuff of theory, are now being tested in labs. The success of such missions would mark a turning point, transforming humanity from passive observers to active explorers of the interstellar realm. The object's brief visit has also reshaped our cultural perspective. It's not just scientists who are captivated. Oumuamua has sparked stories, art, and debates about our place in the universe. It's a reminder that the cosmos is vast, unpredictable, and full of surprises. Whether it's a rock, a relic, or something else entirely, it has stirred our curiosity, pushing us to ask questions we might never have considered. What other travelers are out there? How many have passed through unnoticed? And what might we learn if we could catch them? The data from Webb has given us a foundation, but it's only the beginning. Future telescopes, like the Nancy Grace Roman Space Telescope, will peer even deeper, searching for faint signals of interstellar objects. Spacecraft like those proposed by Breakthrough Starshot could one day visit these visitors, collecting samples or even landing on their surfaces. Each mission will build on what Oumuamua taught us, refining our tools and our understanding of the galaxy. Reflecting on Oumuamua's journey, it's hard not to feel a sense of awe. This object, older than our solar system, has traveled farther than we can imagine, carrying the story of its origins across the galaxy. Its passage through our system was fleeting, just a moment in its billion-year odyssey, yet it left an indelible mark. It's a reminder that the universe is alive with motion, with objects crossing vast distances to connect one star to another. We're just beginning to listen to their stories. The questions Oumuamua raises are as important as the answers it provides. Why did it accelerate? What forged its strange shape? Is it a natural wanderer or a crafted relic? These mysteries drive us forward, fueling the next generation of explorers. They remind us that the universe is not a static backdrop but a dynamic stage, where objects like Oumuamua play roles we're only beginning to understand. As we look to the future, Oumuamua stands as a beacon. It's a call to build better tools, ask bolder questions, and dream bigger dreams. The galaxy is vast, but our curiosity is vaster still. This interstellar visitor has shown us that the cosmos is full of possibilities, waiting for us to explore. Its legacy is not just in the data it left behind but in the ambition it sparked, a desire to reach beyond our world, to touch the stars, and to uncover the secrets they hold. In the end, Oumuamua is more than an object. It's a symbol of the unknown, a challenge to our understanding, and a promise of discoveries yet to come. Its journey through our skies was brief, but its impact will echo for generations.